Okay, so today in class we ended with a problem that looks similar to this one. It says, let me turn this a little bit. We are given a projectile launched at 50 meters per second at a 37-degree angle, and we wanted to know how high the projectile would go. We said that that's actually all the information you need to solve the problem, but the first thing you're going to do is separate your vertical and horizontal components of your motion. So we went over here and figured out that the vertical component is opposite the 37-degree angle, so that was 50 sine of 37, which came out to be 30 meters per second. And the horizontal component is adjacent to the 37-degree angle, so we use cosine. 50 cosine of 37 gives us 40 meters per second horizontal velocity. Okay, so to figure out how high the projectile is going to go, we really need to know how, we need to know the time that it's in the air, and that all really depends on the vertical direction. The horizontal direction really happens independently of the height. So we're going to first try to figure out how high it's going to go, only looking at the vertical direction. The height that this is going to go to is going to be exactly the same as if we just had launched something vertically, straight up, at 30 meters per second. So we're going to look for how high would that go if you launched something straight up at 30 meters per second. So I'll go back to the black so you can see it better. We're going to look at the y direction. And what do we know in the y direction? Well, we know that the initial velocity in the y direction, VIY, is 30 meters per second. And you might even put a plus on there because it's 30 meters per second up. We know that it's accelerating. And we know that it's accelerating at 9.8 meters per second squared down. Now here's the first, well, not the first time, but this is one of those times when you want to use a negative 9.8 because the projectile is starting to go up, but it's accelerating downward. So it's going to be slowing down initially. So negative 9.8 meters per second squared. And we also have to know one more thing. So if you'll recall from before when we were doing projectiles just launched straight up, remember what happens at the top of the motion. For an instant, the velocity becomes 0, and we can use that, VFY. We'll call it the final, but it's really at the top. VFY is 0, and I might even, for now, write this at the top so I can keep straight what's going on. So now I know three things, and I'm looking for how high it goes. We're going to call that, well, we could call it delta S in the y direction, or based on the picture, we might call it H. And that's what we're looking for, so we're going to find an equation that has all that stuff, which is VF squared equals VI squared plus 2A delta S from your note card, the time-independent equation. And we have final velocity is 0, initial velocity is 30. We can do 30 squared plus 2 times negative 9.8 times delta S, which we don't know. 30 squared is 900. 900, I'm moving over to the other side, so it's negative 900 equals negative 19.6 delta S, and divide both by negative 19.6. And delta S becomes a little over 45. Plug in my calculator. One that works would be good. 900 divided by 19.6 gives me 45.9 meters. And there you have it. That's how high the thing is going to go. Now another question that they'll often ask you for is the range. In order to get the range, you need to know how long it's in the air, and we have not done anything with time yet. In the way that we calculated how high it would go, we just didn't care about that. So we need to do the time in order to figure out how far it's going to go. B. Actually, I'll erase over here. You're not going to have space. So B is how far does it go in the x direction? horizontally. And to do that, we need to know time. But the time doesn't depend on the x direction. The time depends on how long it's in the air. How long it's in the air comes from the y direction. That's what we're going to be interested in. Need time, and we're going to have to get that from the y direction in this case. So, we know, again, that the initial velocity in the y direction is 30. We know that it's accelerating downward at 9.8 meters per second squared. And we're looking for time. Now, we could do this in a couple of ways. One of the things that we could do is exactly what we said before. If we know that at the top its final velocity is 0, we can figure out how much time it takes to get up. And then since projectile paths are parabolic, we can just double that time to figure out how to get to the other side. It's symmetrical. The other way we could do it would be using the fact that this is not changing height from here to here. So we might say that delta Sy from beginning to end is 0. I'm going to go the first way. It's a little more intuitive for most people to understand that if I can get time up, I can just double it to get the total time. So I'm going to go with Vsy equals 0 at the top, which is exactly the same information we used in the last part of the problem. And then I'm going to look for an equation that has those along with t. I have Vi, A, Vf, and t, which means I can use Vf equals Vi plus At. 0 equals 30 plus A, but that's really minus 9.8 times t, and t comes out to be just over 3 seconds. I can do 30 divided by 9.8, gives me 3.06 seconds. But that's only t up, because I was, again, only going to the top. So that's t up. T total, and this is where you have to be careful, you just can't forget this little step. T total is going to be double that, or 6.12 seconds. And note, the only reason you can double it is that it is returning to the same height. If it were going down further at the end, or if it wasn't going as far, then you wouldn't have the symmetrical parabola. You wouldn't have it continuing just as far, so you can't just double it. But in this case, because it's starting and ending at the same height, you know you have perfectly symmetrical, and you can just double your time. Double time because it ends at the same height. So that gave us the time it was in the air, but that's not the end. They didn't ask us for time. They asked how far does it go horizontally. Well, recall, the only equation we have for the horizontal direction is this one. Delta Sx equals Vix times t. Initial velocity in the x direction, because velocity in the x direction is a constant, times the time. So initial velocity in the x direction was 40. Time, we just figured out, was 6.12 seconds. And we're going to multiply 40 times 6.12 to get 240. .8. Let's round it to 245. And that's a distance, so its units are meters. 245 meters is how far it goes in the x direction. Okay? That's probably enough for today. There's a lot more that we can calculate. In your homework, just go up as far as finding the maximum height, the time up, the time down, the range. I think you should be able to do most of that problem for homework now. Thank you very much, and I'll see you in the morning. Have a good one. Bye.